So once again, back at scientific notation, what if we have a number that is much smaller than 1? How would that look in scientific notation? So once again, we have to make sure that we put our coefficient, which is basically the regular number. We also have a base 10, and we have an exponent that we have to put our format into. So remember, in scientific notation, when we put our numbers in scientific notation, our number will be greater than or equal to 1, but less than 10. So let's look at this number in the purple. This number is much smaller than 1. This is when we talk about numbers that are either much larger or much smaller. Here is a much larger number, a much smaller number, very, very small number. That could represent anything. It could be the cells in your body, or it could be atoms. It can be something very, very, very small. But if we were to put this number into scientific notation, we have to create a number that is, well, our coefficient needs to be greater than or equal to 1, but less than 10. That means that I need to get my decimal point in between this 3 and this 4 here, because that will give me a number that is greater than or equal to 1, because 3.48 is greater than 1, but it is less than 10. Now, if I put the decimal point behind the 4, if I was actually going to put the decimal point behind the 4, I would have 34.8 or 34 and 8 tenths. But that would not qualify, because that number would be greater than 1. But it will not be less than 10. Remember, the rule says that in scientific notation, the number or the coefficient needs to be greater than or equal to 1, but less than 10. So I don't want to put the decimal point behind the 4. I don't want to put it behind the 8. I want to put it in between the 3 and the 4, so it can follow the rules of scientific notation. Alright, so now what I have to do is I have to find out how many decimal places, and once again, I'm not going to count the zeros. I'm going to count the decimal places it's going to take me to get from this point right here to this point over here, in between the 3 and the 4. So let's do it. So if I start here, don't worry about that first 0. And once again, I said don't count the zeros anyway. If I start here at where the decimal point is, let's count how many decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. So we can start writing our number into scientific notation now. So if I write this in scientific notation, it's going to be 3.4 or 3 48/100 as my coefficient. I'm going to multiply that times base 10. And how many decimal places did we move again? Let's count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I had to move from the left to the right, and this number is less than 1. So our exponent will not be positive. It will be negative this time. So it's going to be a negative 10. So it's going to be 3 48/100 times 10 to the negative 10th power. And now we have our number written into scientific notation. And we need to have this, because if we want to rewrite this or write it back into standard form, which is in the purple, that's standard form, then we need to know that negative 10, or if it's positive 10 or negative 10. Negative 10 indicates that the decimal point would have to go to the left. We'll work on converting from scientific to standard in a later video. Let's try another one now. This number is a little bit smaller, not too big. So once again, as I mentioned before, do not count the zeros, because in this case we have a significant 0 here. And if you count the zeros, you will more than likely write the wrong scientific notation. You will write this number, it won't be in scientific notation as you want it to be. Alright, so as I said before, count the decimal places. So I want to get a number that's greater than or equal to 1, but less than 10. That means that the decimal point needs to land in between the 5 and the 0. And we're starting here. How many decimal places do we move from the left to the right? 1, 2, 3, 4 decimal places. I'm just going to put the 4 here. Alright, now we can start the process. Our coefficient is 5. We keep this 0. We don't get rid of it. It's a significant 0. We have to keep it. So 5 and 8/100ths. We're multiplying times the base 10. So times 10. And we moved 4 decimal places to the right. So it's going to be times 10 to the negative 4th power. And we need that. So if we want to convert it back into standard form, we'll know which direction the decimal point needs to go. So now this number is written into scientific notation. It meets the requirements of a number or a coefficient that is greater than or equal to 1, but less than 10. And this is what we have here. Like, comment, leave some feedback. Tell me if you learned something about scientific notation. Thank you for watching, and I will see you in the next video.